We're going to solve now one complete equation for mechanical vibrations with damping and outside force. So the general equation is written here. All the coefficients are positive. M is mass. We have damping coefficient and coefficient K characteristic for the system. And the equation is forced by F big of T, outside force, which can be usually periodical or another function. So let's solve this problem. Solve the equation for vibrations where the mass is 1, damping is 4, K is 5, this coefficient, and the outside force Ft is negative 23 cosine 2t and negative 11 minus 11 sine 2t. So the outside force is periodical with frequency 2. Okay, so to solve the equation, first we construct it with the given coefficients. This will be the equation: x second plus 4x prime plus 5x equals negative 23 cosine 2t and minus 11 sine 2t. And let's take initial conditions: x0 to be 0, x prime 0 to be negative 1. Now, to solve this equation, as you know, we follow certain steps. So here is step 1. We solve the homogeneous equation. We solve x second plus 4x prime plus 5x equals 0. For convenience, for convenient references, the original equation I shall underline in green, make it more visible, and this equation we will call equation star, and the homogeneous equation will be equation 2 stars. Now we're solving the homogeneous equation. We go to characteristic equation. The first thing to do: r squared plus 4r plus 5 equals 0. From here, by the quadratic formula, r equals negative 4 plus minus square root 16 minus 4 times 5, which is 20, divided by 2. We have a complex number here. 16 minus 12 is negative 4. I can write this root negative 4 over 2. This will be, of course, root of negative 1 root of 4. So this will be 2i divided by 2. And finally, we have a complex number, negative 2 plus minus I, complex root. So we define two real independent solutions for the homogeneous equation. x1 will be exponential minus 2t cosine t. x2 is exponential negative 2t sine t. Two independent solutions for the homogeneous equation, and we write general solution for the homogeneous equation. X sub h to indicate homogeneous, This will be factoring the common exponential, a cosine 2t plus b sine 2t. Here, this is general solution for the homogeneous equation. If we have no outside force, I'm sorry, let's make a correction here. I was carried away. It's not cosine 2t, sine 2t, just cosine t and sine t here. So quickly removing this, let me make this better. Okay, cosine t and here sine t. The frequency of the system is 1. It's the coefficient in front of this complex unit I. It's 1. And the frequency of the outside force is 2. Different frequencies. Okay, this was the end of step 1. Now we're going to step 2. In step 2, we have to produce a particular solution for the original non-homogeneous equation. To do this, we look at the right-hand side and we match it this way. We're looking for a particular solution, coefficient 8 with cosine 2t, plus a non-coefficient b, sine 2t. I'm using a and b small letters here. These are quite different from the big a and b. A and b here are undetermined coefficients. And how to find them? We shall differentiate twice, substitute in the equation, and compare coefficients. So here we go. The first derivative will be negative 2a sine 2t. Chain rule, coefficient 2 comes in front, and here we have plus 2b cosine 2t. Then we got the second derivative, negative 4a cosine 2t minus 4b sine 2t. And then I want to substitute this in the non-homogeneous equation. So I have to collect xp second plus 4 times xp prime plus 5xp. I shall do it this way. So we multiply xp by 4 and write it here on the next line. And I shall rearrange it to have the term with the cosine coming first. This is for easy computation. So I multiply this line by 4 and write it here. There will be 8b cosine 2t minus 8a sine 2t. And then we have 5 times xp. This will be 5a cosine 2t and 5b sine 2t. So we're adding these 3 lines. On the left side we have xp second plus 4xp prime plus 5xp. So this will be after collecting coefficients. You see on the first column I have only cosine, second column is only sine. I just need to collect the coefficients and write negative 5a. This will be just a plus 8b. This is coming with cosine 2t. See how it becomes much faster when you organize it properly. And the coefficient in front of sine 2t will be, let's see, this will be negative 8a, I'm putting a first, and plus b, sine 2t. This is the form when we substitute xp on in the equation. We want this to be the right-hand side. So let's look again what was the right-hand side. It's negative 23 cosine 2t, negative 11 sine 2t. So we set this equal to negative 23 cosine 2t and negative 11 sine 2t. If this is fulfilled, if we choose A and B such way that this will be true, then we have a good particular solution. XP will be a particular solution. So now we have to determine what are A and B in order this to be true. So we compare coefficients. In front of cosine, let's underline like that. And in front of sine, this should be equal this. That's 11, not 4. Let's make a better 11 here. Better 11. Okay. So comparing coefficients, we have these equations. A plus 8b equals negative 23. Negative 8a plus b equals negative 11. Very simple. A system of two simultaneous equations, A and B are unknown. How to solve it? We can do substitution or we can do elimination. Because elimination is always better, I shall do it here, and then when we start with linear algebra and solving systems, we shall do mostly elimination. I can eliminate b. If I multiply the second equation by negative 8, make the coefficient in front of b negative 8, and the equation will become 64a minus 8b equals 88. And I shall rewrite the first one here. A plus 8b equals negative 23. Adding these two, b disappears, you see, and we have 65a equals, and on the right side, 65 again. So we find that a is 1. Then to find b, we can use one of these two equations. For instance, the second equation here, b will be 8a minus 11 from the second equation. And we know a is 1, so b will be 8 minus 11 will be negative 3. So here we have b equals negative 3. After finding these two numbers, I can now write my particular solution. The particular solution will be cosine 2t minus 3 times sine 2t. So this function satisfies our differential equation. This is the end of step 2. Here comes step 3. I write general solution for the non-homogeneous equation. It's always written this way. X equals xp plus x sub h. The particular solution we found is step 2 plus general solution of the homogeneous from step 1. In expanded form, this is the general solution. Cosine 2t minus 3 sine 2t plus general solution of the homogeneous was this. A cosine t plus b sine t. And this is actually the step of the end of step 3. Let's underline this important general solution. Okay, now remember we have initial conditions and we go to step 4. Computing A and B. Remember x0 is 0, x prime 0 is negative 1. I want to repeat that we compute the coefficients at the very end, not in step 1. Okay, so in the general solution of the non-homogeneous equation, we set t equals 0. Here x is underlined with green, x 0 is 0. And what will this be? Cosine will be 1, sine is 0, exponential is 1. Inside the parentheses we have a plus 0. So this is a very simple equation. 0 equals 1 plus a, so this big A will be negative 1. And now we have to find B. We have to differentiate x prime t will be negative 2 sine 2t minus 6 cosine 2t. And the second term we differentiate using product rule. So first exponential, negative 2 exponential negative 2t. Inside we have the same thing, a cosine t plus b sine t. And now we keep the exponential and differentiate inside the parentheses, which gives negative a sine t plus b cosine t. This is the derivative of the general solution. We set t equals 0 and x prime 0 is negative 1, which gives, let's see what happens here, this expression. Sine is 0, cosine is 1, so minus 6. Then we have minus 2, exponential is 1. Cosine here in this position is 1, and a is negative 1, so there will be negative 1 from here. Sine is 0. Going to the last term, exponential is 1. Inside the parentheses, we have 0 plus b. This is equation for b. Let's write again. Negative 1 equals, there will be negative 6 plus 2, so negative 4, and plus b. So b will be 4 minus 1, 3. So we found these coefficients. Now our solution is this. Xt, here first the particular solution, cosine 2t minus 3 sine 2t, and here plus exponential negative 2t, and replacing a is negative 1, so negative cosine t plus 3 sine t. Here our solution that satisfies the initial condition. I am also underlining by green. And then in this problem we're having another step, the final one, which is step 5. We write the particular solution in standard form. The particular solution is more important than the general solution of the homogeneous. Let's look again at the general solution. Here, first is the particular solution, then general solution of the homogeneous. It includes this exponential which approaches zero. So after a long time, after some time, the solution for our system will be similar, will be close to the particular solution when t is large. So the particular solution is actually ruling the motion, determining the vibrations, and they will be with frequency too, like the outside force. So that's why the particular solution is very important, and people work with this when they want to study certain vibrations. It's called steady state solution, and the other one, exaBase, is called transient because it comes and goes. What is the standard form? I shall write again. Particular solution was cosine 2t minus 3 sine 2t. I want to put in the form c, amplitude, cosine, frequency here is 2t minus alpha, where alpha is the phase shift angle between 0 and 2 pi. Can be 0 but not 2 pi. It's always positive angle. C is the amplitude. C is defined square root 1 squared plus negative 3 squared. So this will be square root of 10. And then cosine alpha is a over c. Remember, a is now this coefficient that we use here. It will be 1 over root of 10. Sine alpha will be negative 3 over root of 10. We have to determine alpha from here. Cosine is positive, sine is negative. This is fourth quadrant. Fourth quadrant. The situation is this. Alpha is somewhere here in the fourth quadrant. And how can we compute alpha? We shall compute alpha 1, this negative angle. Alpha 1 will be inverse sine negative 3 over root of 10. It's a negative angle. And the real alpha will be 2 pi plus this. I'm writing plus because this angle is negative. It's like subtraction, and so we're removing alpha 1. We have alpha, the real angle. Another way to do it, I can write alpha 2 pi minus inverse cosine 1 over root of 10. You can consider angle alpha 2 where symmetric to alpha 1 with the same cosine. And inverse cosine of this number will give you exactly alpha 2. So that's the angle alpha 2. Okay, we're practically finished. So I'm writing the particular solution in standard form now. C is root of 10. We have cosine 2t minus alpha. So it becomes 2t minus 2 pi. Let's use the second version, and then plus inverse cosine 1 over root of 10. Look, this is our particular solution in standard form. If you want to study this motion, to graph the solution, you can work with the XP for large time, because this is representing the motion very well. Okay, end of our lecture. Goodbye. You will see on Moodle other examples, and please study them carefully.